What's going on, everyone? Patrick here. Moving on to the next question on the test. We have the population of a region is modeled by the function pt equals 0.4t squared plus 8.7t plus 32, where p of t is the population in thousands and t is the time in years since 1998. And we got 3 questions to answer. So starting off with part A, what was the population in 1998? Okay, so notice the t value is the time in years since 1998. So if we have a t value of 0, what year does that represent? That represents 1998. So a t value of 1 would be 1 year after 1998, so that would be 1999. And then a t value of 2 would be 2000. Etc., etc. So when they ask you what was the population in 1998, basically you're plugging in 0 for t in the function. So you're looking for p of 0. So if we plug in 0 here, notice this expression will go to 0 because you'll have 0 squared here, and then 8.7 times 0, this expression will go to 0 as well. So you'll just be left with 32. However, the population is expressed in thousands. So basically whatever number you get here, you have to multiply by 1,000. That gives you the actual population. So 32 times 1,000, that gives you 32,000. So that was the population in 1998. If they were asking for the population in 1999, you would plug in 1 for t, get that number, multiply it by 1,000. So part B, what will be the population in 2012? So in 2012, how many years have gone by since 1998? Well, 2012 minus 1998 gives you what? 14? So if you follow this pattern, if you keep it going, at a t value of 14, you would have 2012. So what they're asking for in part B is basically p of 14. We're plugging in a t value of 14 because that represents the year 2012. 14 years after 1998. So it would be 0.4, 14 squared, plus 8.7 times 14 plus 32. And when you do that in your calculator, you end up getting 232.2. So take that, multiply it by 1,000, and you get 232,200 people. So that was that's what the population will be in 2012. And then part C, in what year will the population be at least 300,000? So this question is going to take a little bit more time, because we're not going to be plugging in a value for t and just getting the population. We have to now plug in a population and solve for t. Now, you got to be careful here because you don't plug in the whole 300,000. So you don't write 300,000 equals 0.4t squared plus 8.7t plus 32. Right? This is a common mistake that students make. It's because the population is expressed in thousands. So remember when we got the population in parts A and B, we had to multiply it by 1,000. Well, when we input a population into the function, we got to divide by 1,000. So we wouldn't plug in 300,000 here. We would just plug in 300, like that. Right? So be careful with these types of questions when you're plugging in that population. If it's in millions, you got to divide it by a million. If it's in thousands, you got to divide it by 1,000, like in this case, and you plug in that number that you get. And then on the other side, if you solve for the population, you got to multiply it by whatever it's expressed in. So in this case, we multiply it by 1,000, but if it would be expressed in millions, multiply it by a million. And then from here, this just becomes a quadratic equation to solve. So you would put in 0 equals 0.4t squared plus 8.7t. You know what, let me space these out. I hate using the variable t because I always confuse it with a plus, so 8.7t. And then bring the 300 over, 32 minus 300, that gives us negative 268. Right, so we just have a quadratic equation to solve here. And you could try to factor this. I don't think it's going to factor smoothly, so I wouldn't recommend it. I would just throw this in the quadratic formula at this point. If you remember, quadratic formula in general is what? Negative b plus or minus square root of b squared minus 4ac all over 2a. So negative b, so negative 8.7 plus or minus square root of 8.7 squared minus 4 times a, which is 0.4, times c, which is negative 268. And this is going to be all over 2 times 0.4. And when you do that in your calculator, you'll get these two values here. So 17.2 and negative 38.95. Now the negative value you just ignore, because t, if you remember, represents the number of years since 1998. That has to be a positive number. It can't have a negative. So you would ignore that. And this here is your answer. So what does this mean here? Well, if you remember that chart I initially made with the value of t, where a t value of 0 represented 1998, and then a t value of 1 represented 1999. Well, a t value of 17, if you follow this pattern, basically 17 years since 1998 is 2015. And then a t value of 18 would be 2016. So because this is 17.2, the population is going to reach 300,000 in between here, right? So some point in 2015. So in what year will the population be at least 300,000? Answer is in 2015, somewhere in between 2015 and 2016, right? So that year 2015, that's when it's going to happen. So that is the answer. So you take your t value, add it to 1998, and you get 2015. Right? So with these types of questions, just be careful with the number of units that are expressed for each variable. So the population is in thousands. Whenever you solve for the population, got to multiply that number by 1,000. Whenever you plug in a population, you got to divide that number by 1,000.